Next topic will be algebraic presentation of saving function. As I said before, this saving function, it is the functional relationship between income and S, right? So functional relationship, it is in this form, right? So S is equal to negative saving plus instead of this one, we can also write it like this. Okay, plus 1 minus by. All right. Now we can say these are the components of saving. Okay. Now what is this? Very simple. This is saving. We need to go for description of the components of saving. What is this now? Or this one? So this is autonomous saving, right? So what is this autonomous saving? When income is 0, we are getting a negative saving. That is how much? 20. This is autonomous saving. Is that clear? Okay. Then what is this? Instead of this one, we can also make use of this one. What is this? C bar. C bar is this one, right? This is C bar, which is given 20. This is autonomous consumption, right? Now, which is given 20. And now minus C, 20. What is it? So this is this one, right? All right. Okay. Okay. So you can use anything here in this. Plus, now what is this? 1 minus B here. Remember, B is what? B in consumption function, it is MPC, marginal propensity to consume. Okay. Now, 1 minus B is equal to MPS. Okay. So MPS, we are getting formula. 1 is upon delta Y, and MPS will be 1 minus MPC. All right. So 1 minus B will be equal to MPS. Then this is income. Y is income here. All right. Now this is what? Saving function equation. Now it's very easy to derive saving function from consumption function if it is given. Okay. Now just I'll make one consumption function. All right. The same thing what we have done in this schedule. What we have done here using consumption, these two consumption functions schedule, I have derived saving function here. All right. Now in the form of equation, we will see. See here, C is equal to C bar plus BY. What is it? This is the consumption function equation, right? So this is autonomous consumption plus this B is what? MPC. This one B is MPC and this is Y is income here. All right. Now using this table, see here. C is consumption. C bar is how much? C bar is this one. That is autonomous consumption is 20. Plus B MPC. Last video. MPC we are getting 0.8. Right. And into we have different levels of income. Here. All right. Okay. Now using this one, we can derive saving function. S is equal to, now S is what? C is 20. S will be how much? This one, right? So minus 20 plus 0.8. MPC is 0.8. MPS will be, so 1 minus MPC, so 1 minus 0.8, 0.2. So we can say 0.2. Are we getting here? See 0.2 MPS, then Y. So this is the consumption function equation and this is the saving function equation. All right. Okay. So this is about algebraic presentation of saving function. So in the meaning I said, what is the saving function? Saving function is the functional relationship between saving and income. So when we are talking about the functional relationship, it represents the algebraic presentation or mathematical presentation of saving function. All right. Okay. So again, these are the components of saving. Okay. Okay. Now, next one, we will see the derivation of saving function from consumption function. All right. Okay. Derivation of S function from C function. Again, in this, we have to use the schedule. Derivation of S function from C, that is consumption function. So this one, in this, we will show the diagrammatic illustration. All right. So first, you need to go for consumption schedule, right? So we have to make consumption function schedule. Here, the same. C is use this schedule, draw consumption function schedule. Okay, now derivation of S function from C function. S function is saving function, right? And we have to derive saving function from C function, that is consumption function. Okay, so using this diagram, we will see the derivation process. All right. Now, this is your consumption function diagram, which I've drawn in my last video. And today, just now, we have seen the saving function diagram. Right. Now, to draw this too, again, what we have to do, use this schedule. Or you can go for any other schedule too. All right. Okay. So I've used this schedule, and on the basis of it, consumption function is drawn as well as saving function is drawn. Is that clear? Okay. Now let's see the derivation process here. Now again, this description in detail I have done in consumption function video, and this one also just now. Now let us see the derivation process, how we have to go for it. The first one is, so we can say by using this diagram or by using this schedule, that is consumption schedule, we can derive saving function, right? So on the basis of this one, we can draw this saving diagram. All right. The first observation that we have to go here is saving line. This, right? This is the saving line. Okay. So it starts from where? Again, it starts from this one. All right. Minus 20. When income is 0. You can also make use of schedule or either diagram for the description. All right. And this is what? Minus C bar, or this one will be S minus saving, negative saving. Okay. So this is autonomous saving. All right. Then we can say here, so here I said when income is 0, we are getting negative saving this much. And how about consumption? Consumption is this much. C is equal to 20. All right. Okay. So we can say here, we will take it like this. This will be A and this will be B. Okay. And here C and D. So in this, A and B of saving is equal to, so we can say is equal to D and C. All right. One thing. Second one is S line, saving line, is crossing x-axis. Crossing x-axis. So I said this one is what? Break even point. Break even point. What is happening here? So saving line crossing x-axis. Okay. We can say, or from this, that is from this point, break-even point. So at this break-even point, what happens? So we can say here, break-even point where saving is equal to 0. at this break-even point, it shows S is equal to 0 here. So now look, when saving becomes 0, when here, what is happening here? Y is equal to C. So saving will become 0 when Y will be equal to C. Right? So see here. Alright, there will be no saving when income is equal to consumption. Alright? Okay. Then the third one is slope of saving line. So I'll rub this. Third one, right? Slope of saving line is equal to 1 minus slope of C line. Slope of saving line is equal to 1 minus slope of C line. Is it? Now see here, slope of S line is indicated by what? Is indicated by MPS. Right? And slope of C line is equal to 1 minus slope of C line is indicated by what? MPC. Right? So again, slope of S line is a straight line. Straight line has a constant slope. Okay, and this straight line is shown by MPS. So MPS, it has to be constant. Right? We got constant MPS. Similarly, same thing happens here. MPC. Okay. Now see here. MPC, how much? We got 0.2, right? So let us see if we are getting it or not. Is equal to 1 minus MPC is 0.8, right? In my last video, MPC calculation, we got 0.8 and it has remained constant, right? So 1 minus 0.8 will be 0.2. Now see here, MPS is 0.2 here. All right, okay. Then the fourth one, saving line is a linear function, or we can say linear function. Linear saving function, we can say. S line is a linear function. What does it mean? S line is a linear function. It means what? It is a straight line. So we can say here, a straight line saving function. Linear saving function is a straight line saving function in which MPS is becoming what? Remaining constant, or it remains constant. Okay. Is that clear? Okay, so linear, I will say linear saving function. Saving function. Or the fourth point, you can write it like this. S line is a linear function. So what does this linear saving function means? It is a straight line saving function in which MPS will remain constant. Similarly, in consumption function also we are getting what? C line is a linear function. Okay, we call it as linear consumption function. So what is this linear consumption function? The same thing. It is a straight line consumption function in which what is happening to MPC? It is remaining constant here. Alright, okay, so this is how you need to go for the description on the derivation process of S function from C function. Alright, okay, so this is all about saving function, and all this theoretical information, especially the equations, you will be using for solving numerical illustrations. Alright, and you need to keep in mind the theoretical information which is given in this. So like this is all about saving function. So a brief recapitulation you see. The first one, it was, we said, we have started here, y is C plus S. That means C consumption, S is saving. So both consumption and saving are determined, or we can say it depends on income. Okay, so it is very easy to calculate C as well as S by using this. Alright, okay. Next one, I said saving function. What is this saving function? Now saving function, functional relationship it shows, right? So when we are talking about the functional relationship, it means mathematical relationship or algebraic relationship, okay, which is in equation form that I have shown here. Next one, we went for saving function schedule, right? So I said consumption schedule and saving schedule are related, or C and S are related. If we know the C, then we can easily go for the calculation of S. Alright, so schedule in the form of a table, I have used consumption function schedule. On the basis of it, I have made saving function schedule. Alright, an observation we have seen. Then next one, diagrammatic presentation of saving function, right? Now on the basis of consumption function schedule, on the basis of consumption function schedule, drawing saving function schedule, and on the basis of saving function schedule, I have drawn the diagram and observation we have seen it, right? And in the observation, one thing which is very important is about the shape of S line, which we are getting in straight line, right? So straight line, saving line has a constant slope, I said. So this straight line saving function is shown by MPS. Is that clear? So MPS, it has to be constant. And we got MPS constant. Alright, okay. Then after that, we went for algebraic presentation of saving function. In that, the description was on the components of saving equation. Is that clear? So, using equation, okay, if we have consumption function equation, we can easily derive the saving function equation also. Alright, and the final presentation is about the derivation process. Okay, for derivation process, what we have to do is we have to make schedule again. We have to make use of consumption schedule to derive saving function schedule, and by using consumption schedule, go for consumption function diagram, as well as on the basis of it, draw the saving function diagram. Is that clear? Okay, so I'll write here the consumption function equation. C is equal to C bar plus by, and here S is equal to S bar plus 1 minus by. So this is all about the saving function.